Well, hi again. Well, we're having a great time with these continuous random variables, aren't we? And today we're going to have a look at measures of spread for a continuous random variable. There it goes. Okay, off we go. Well, the first thing we're going to consider today is variance and standard deviation. You might recall that we looked at those same little beasties when we were doing the discrete random variables, and the principles of the way they work in continuous random variables is exactly the same. So, the standard deviation, everybody, is the average deviation from the mean. That's what it actually means, okay? So if you took all of the values in that distribution of, say, x, and then you worked out the mean, and then you took the distance that all of those values individually were from the mean, and you took the average of that, you'd have your standard deviation. So it's a measure of spread, and it's denoted by Greek capital sigma, little sigma, okay? Standard deviation, and of course, by the way, mu is a symbol we use for the mean or the average, okay? Now, I think you're also probably aware of the fact that variance is the standard deviation squared, okay? So, and that is sigma squared, okay? So the variance is basically the integral of x minus mu all squared times the probability of that, which is f of x dx, okay? And it's the sum of all those things. So that thing, that Leibniz snaky looking S thing, means the sum of, that's the deviation from the mean squared actually, deviation from the mean squared, times its probability, which is f of x dx, okay? Probability of that value. And it's all those values added up, and that'll get you the variance, okay? And then take the square root of that to get the standard deviation. Now, what I'm going to do is I'm going to show you, if you fiddle with that very abstract looking piece of stuff there, piece of work there, if you fiddle with that and start expanding it and fiddling with it, you'll see that we get exactly the same formula as we did for the discrete version. So I've multiplied out I've made a quadratic expression out of this thing here, made it that there, got turned into that there, into a quadratic expansion, and now I'm turning those three terms, 1, 2, 3 times f of x dx into three separate integral terms, okay, like that. Alright, and see how we go. Now, the first thing there, that's the expected value of x squared, okay, you get that? That's the definition of the expected value of x squared, right? And this one here, this second one, is basically 2 mu times, now that is the expected value of x, get it? Good, okay, and the third term, well, you know that the integral of f of x with respect to x, if it's a continuous distribution worth its salt, that's got to be 1, doesn't it? Yes, so therefore we get plus mu squared times 1. Right, well, it's looking a lot simpler now. Let's do another line, see where we end up. Yes, same thing there. And look at that second term. That second term, that e to the x is just obviously the expected value or the mean or the average, which we call mu anyway, doesn't it? Isn't it? Yes, it is. So look, it's looking extremely friendly now. Let's do another line. Yes, look at that. Now, the second and the third terms are just going to be combined into minus mu squared, aren't they? Hello, Mr. Thumbs Up. Oh, you're doing a shift tonight. Very nice, and nice to see you too. So that equals e, yeah, the first term's the same. That term's the same as what we had in the line down there, that term there. Yeah, and then we've got minus mu squared. Now, of course, mu, in another way of saying it, is e, yeah, the expected value of x. So that, ladies and gentlemen, is the same formula as we had for the discrete distribution. Yeah, it's the same thing, okay? Excellent, right? So that's the one you use. That's the one you use to get the variance, okay? And then you get this, same as for the discrete, and then the standard deviation, of course, is just sigma, which is the square root of the variance, okay? How's that, Mr. Box? Thanks. All right, so I thought I'd do all that theory for you just to show you the pleasant surprise at the end, okay? And it was a pleasant surprise, wasn't it? Okay, let's see what else we've got for you today. Find the variance in the standard deviation. This is an example of what we just found. The variance in the standard deviation of the random variable x, which has that probability density function with that rule. Well, come on, we know how to do it now, don't we? F of x looks to me to be x over 2, or 0.5 of x, and it only goes from x is 0 to 2, so we can do that. Come on, we can do it. So that's, yeah, that's the formula we got over the page, isn't it? Now, do you know how to do that, guys? That's the $64,000 question. Do you know what to do? Yes, I hear you say. Well, that's very encouraging. Look, does that look right? I think so. And what's f of x? F of x is just 0.5 of x, isn't it? And I'll put the 0.5 outside because that's a constant and we don't want it clogging up the integrator and making us even more confused than we already are. All right? Now, I think I'm going to simplify that a bit. First of all, do you agree with what I've written? Come on, own up. Yes, you do. All right, that's very good for you. Okay, now I've just consolidated all the x's behind the integral signs, and I've taken that in that second term there. I've taken that half. I've squared that half and made it a quarter down there, so it's now outside the square bracket. Okay, I just felt like doing that for something completely different. Now, what do we get now? I've integrated. Do you agree with what I've written? Good. Okay, another line, I feel. Good. So does that make sense? That first term. Yes, that's 2 to the power 4 minus 0 to the power 4, which is nothing. And the second term we get a quarter of, yes, x cubed with x being 2 would be 8 over 3. And of course that's squared and minus, same thing with 0 squared, which gets us nothing. So I think we're on track, don't you? Good. Now what does that get us? 16 over 8 minus 1/4 of 64 over 9. Good. I can see some cancel-orama happening here. Very good. And very, very good. So where does that leave us, guys? 2 minus 16 over 9. And what is that? Come on, work it out. Do some mental arithmetic for me. Yes, that's 2 over 9, because 2 nines are 18 over 9, minus 16 over 9 gets us 2 over 9. So that is the variance, Mr. Box. Thank you, Mr. Box. Okay, that's the variance. Now, what are we supposed to be doing with this thing? Oh, the variance and the standard deviation. Well, we're nearly there, aren't we? The standard deviation. Hello, Mr. Light. How are you today? You're very bright, I know. And that will be, the standard deviation will be the square root of that, which is root 2 over 3, and Mr. Box. Thank you, Mr. Box. Now, how was that? Come on, you can't say that was hard. Just got to get used to how to do it, guys, and then it's really easy. Easy. Yeah? Good. Now let's go over the page. This is a little practical application for the standard deviation, right? Now, what we say here is, look at that mess, a mess of symbols. What we're saying is that if the random variable, if this little fella here, is between the mean less 2 standard deviations, that's greater than the mean less 2 standard deviations, greater than or equal to, and all at the same time being less than or equal to the mean plus 2 standard deviations, then we're saying that you will have captured basically about 95% of all of the values of x in that distribution. Okay, I'll give you a practical example of this right now. We're saying that the life of a certain brand of battery, x is the life, okay? Not the battery isn't x, the life is x. It's a continuous random variable. It's with a mean of 50 hours and a variance of 16. Find an approximate interval for the time period for which 95% of the batteries would be expected to last. Okay, I'm going to give you a couple of seconds to think about that, because it mightn't be that obvious to you. Okay, I'll give you 5 seconds. Time's up. Come on, how did you go? Well, I think it's pretty easy. Mu is 50, that's the mean, and sigma squared being the variance is 16. So what's the standard deviation, guys? It's the square root of that, which is 4. And furthermore, 2 standard deviations would be twice that, which would be 8. Now that's all we need. We need mu being 50 and 2 sigma being 8. So if we go 50 minus 8, yes, which is 42, to mu plus 2 sigma, which would be 50 plus 8, which would be 58, we would, over that interval, we would cover 95% of battery lives. Okay? Yeah, very excellent, Mr. Box. There you go, guys. Now, come on, that was pretty easy. The trouble is that sometimes these worded questions just get you a bit stuck in the mud, don't they? However, look, practice is the key. All those little synapses and neurons in your marvellous brain will adapt so quickly to this stuff by practice that you will be just so good at it, it won't be funny, okay? I can assure you. Come on, you just need practice. This is, we're going to do range and interquartile range. Now, these fellas were not done in the discrete distribution theory chapter, because it just is a little bit scratchy and titchy trying to do it for a discrete variable distribution. Doesn't come as easily. However, it's really good for continuous ones, okay? And the good news is it's very easy, okay? Easy. So, come on, have a go. The range is the difference between the smallest and the largest value that the variable can take. Right? Now, that's about as simple as it can get, guys. I'll show you in a minute. IQR, that's the interquartile range. This is the range of the middle 50% of the distribution, okay? It's the 75th percentile minus the 25th percentile, which gets you 50% of the population spread either side of the median, right? The median. Don't worry, I'll do one for you and you'll understand, okay? Now there's one for us for the range, okay? Determine the range of the random variable x, which has the probability density function like that. Good. Now what do we do? We've got to find the range. Well, come on, here's your 5 seconds. Go for it. Well, I just plugged this iPad in before it dies on me. Just a minute. Where's the thing? Are you thinking? Come on. It's your turn now. I've been doing plenty of thinking. Yes, alright, well, what is it? Is it minus infinity to plus infinity, or what the dickens is it? Eh? Well, you give in? Right, here I come to the rescue. Well, what is x defined for? It's defined from 0 to 3, isn't it? Yes, it is. So that's the range. The range is 3 minus 0. That's it, it's 3. Oh, I heard you say. Yes, you were looking for something hard, weren't you? Well, it wasn't. Hello, Mr. Box. Thank you, Mr. Box. That's the range. Now, the good news is that was nice and easy. The bad news is they probably won't ask you that on the exam because it's a bit too easy. However, it helps you understand all this stuff, doesn't it? Great. All right, we're going to go over the page now and do an interquartile. That sounds very exotic, doesn't it? Okay, determine the interquartile range of the random variable x, which has the probability density function of that thing. All right, now that's all right, guys. We know how to find percentiles because we did it in the last video. Yes, we did. Didn't you watch it? Well, go back and watch it. The 25th percentile, okay, the 25th percentile means that value of x such that everything up to and including that value of x covers a cumulative probability of 0.25, doesn't it? Yes, and I've called it, the upper terminal there in that integral is Q1, capital Q1. That's what they traditionally call the first quartile or the first quarter. Yeah? So from integral from 0 to Q1 of that function 2x with respect to x equals 1/4. And we solve it for Q1, which you can do just as easily on the calculator, which I showed you also how to do in the last video, as you can do manually here, right? So we're saying x squared, which is the integral of 2x with respect to x, from 0 to Q1 gets us 1/4. Well, come on, plug and play. Yeah, q1 squared minus naught squared equals a quarter. So come on, if q1 squared equals a quarter, yes, q1 equals a half, doesn't it? Yes, that's q1. We've got q1. Now we've got to do q3 now, which is the 75th percentile, the third quarter. Okay, in case you were wondering, the median is called q2. Okay, that makes sense, doesn't it? Yes. So same process, same old, same old. Come on, you know what to do. I don't need to tell you. Very good. Now, therefore, we're saying that q3 all squared would be 3/4. So therefore, come on, what's q3? Thank you, Mr. Oh, we really do love what we're doing, don't we? So, come on, you got it? Yes, well done. Now, therefore, that's not the end of the story. The IQR is the range between those two values of q1 and q3. So it's q3 minus q1. That's the interquartile range, or the IQR as they call it. So there it is, okay? And there, well, I'm just putting it over the same denominator of 2, and it's root 3 minus 1 all over 2, Mr. Box. Thank you, Mr. Box. So do you get that? That's the IQR, and we didn't do that for the discrete variables, but it's really easy. So I think, is that all there is today? Yes, that's all there is. That's all we got for you, and thumbs up, absolutely thumbs up. So that was pretty simple, wasn't it? So that's how to find measures of spread. And do you remember that formula for the variance? What is it? Yes, it's the e of x squared minus e of x all squared is the variance, and the standard deviation is what? Yeah, the square root of that. Yeah? Well done, and thank you for listening, and we'll see you next time. Thank you. Bye.